Okay, I'm here. Did you read the slide?
Oh, sorry.
Do you see this?
Yep.
Okay.
Okay, now. Thank you.
Yeah, you should read it. All right. Okay, what is your question?
I had a quick question about a homework problem, and I was wondering if I could.
Which one? Please
one.
tell specifically homework 1, part what, problem what, so I could read it.
Homework 1, part 1, question 4.
Okay, question 4. 1, 2, 3, 4. Okay, I know this problem. Where's here? What I want, new slide. Come on. All right. So you have a motion diagram. On this diagram, you know certain locations, like X at given time. All right, what's your question?
For the first question, I was able to find the velocity, but I don't know how to find the acceleration at like a certain time.
Well, do you think the acceleration is different at different time?
I think it's constant acceleration.
Exactly. This is the motion with constant acceleration. As soon as we said that, we stop thinking for the moment and we start writing two equations. We hope they could help us, because otherwise, why would you use them at all? Now, this picture provides you a lot of information. For example, you can pick certain time and read the certain value of X. Pick one and read it to me.
Yep.
Please.
I have 0.5 seconds and 0.1 meters.
0.1. I think everybody has the same number, so 0.1 seconds, 0.1 meters.
Yep.
So do you think which of these two equations, 1 or 2, would be the best to use?
I think the first one.
Well, the first has V, V, A, T, and your data, T and X.
Oh, the second one.
I would use the second one as well, because in this equation, well, if you apply this equation to this specific instant, the coordinate has to be equal to something like this. Now, this is what you're looking for. This is your unknown. So if you knew, if you could say something about these two variables to eliminate these variables in a certain way, that would be over. You could solve this for acceleration. Can you tell me something about the initial X?
The initial X can be 0.5.
You cannot choose it. You have to look at the picture and use the value from the picture.
So would it be like where it starts, so at 0?
Well, the word initial means at t equals 0. So at
t equals 0, it's 0 meters.
0. So now can you tell me something about this number, initial velocity?
0.
Why?
Because it starts from rest.
Exactly. That's how we do it. We really find the important word and use it. Because it starts from rest, this is also 0. Now, with all these numbers, now, can you solve this equation and calculate acceleration?
Yes.
Good. Just do it. Although I would probably use a different time. Would be easier if you would use 1, because 1 squared is 1. It's just a simpler calculation. But it doesn't matter,
Okay.
because the acceleration is constant. It does not matter which particular location do you choose, this, or this, or this, or this. The result will be the same.
Okay. Makes sense. Thank you.
Sure. All right. Next question, please. If you can.
Yeah, I had another question too. I wanted to review homework 1, part 1, question 6.
Question 6. What's that? Oh, this is a wrong. Where is it? Here. Question 4, question 5, question 6. A particle moves at a given. Okay. So you've got an equation. You can read me your equation, because different students have different values. So please.
X equals 1.9 t plus minus 3.2 t squared.
Like this, yes?
Yes.
All right. And there are many different questions. For example, average velocity and the instantaneous velocity. Okay, so we need average velocity for a certain time interval, and we need instantaneous velocity at a certain instant. Okay, so please ask a question.
Yep. So for here, for part A, it's between t equals 0.45 and t equals 0.55. Would you plug in both of those numbers to find the x value into that equation?
If you're looking for average velocity,
Yes.
what equation do you have to use? Have to, must.
The equation that's given up above. Or, well, the magnitude of displacement over time.
Exactly.
Delta.
You have to start from a definition. The average velocity, by definition, is equal to displacement over time. So to calculate delta t, you just do this. To calculate delta x, what do? You do this. That's what delta means, the change, the difference between final and initial. So how do we calculate final?
Final would be calculated by plugging in 0.55 seconds into the equation.
Exactly, 0.
Okay.
What is it?
Thank you.
0.55. Sorry, 0.55. You don't have to write plus and minus, right? Just minus 3.2, 0.55 squared. That's going to be your x2. And how do you calculate x1?
By plugging in 0.45.
Exactly. You're replacing time with its actual value. And then you use these numbers in here. There is no other way. That's the only way to do it.
Okay.
Because that's a definition. You cannot redefine it. You just have to use the definition which has been defined before for us. All right. And what did you do about calculating instantaneous velocity?
I was a little confused about that. I think what you do is you plug in 0.51 seconds into the equation and get the x value. And then I'm not sure where to go from
What is the definition of instantaneous velocity?
there. It's
It's the average velocity when the time interval is practically zero.
practically zero.
Practically zero. Practically no difference between T1 and T2. Can you use this definition? No.
No.
No. But we don't have to, because for the motion with constant acceleration, from a definition, we made a transition first to a graph, because acceleration constant, velocity graph is supposed to be linear like this or like that, for the positive acceleration, for the negative acceleration. And then we said that's a linear function, so how do we describe it mathematically? Linearly. And the velocity equation for the motion with constant acceleration looks like this. This is how you calculate velocity at this instant. So this is your instantaneous velocity. To calculate instantaneous velocity, you need to know three numbers: initial, acceleration, and time when you need to calculate. Do you know the time?
Yes, we do know the time. It's 0.51 seconds.
Okay, so this is done. Do you know acceleration?
Yes, it's negative 3.2 divided by 2. Multiplied by 2, so negative 6.4.
Yes, so yeah, just 1.9. So x is equal to 1.9t minus 3.2 t squared. So basically this is the initial times time plus acceleration times time squared over 2. That's why we did the lab, so we could figure out how to find the initial velocity from the motion equation and how to find the acceleration from the motion equation. You are correct. So now, since you know everything, you can use these numbers in the velocity equation and calculate instantaneous velocity.
Okay, thank you.
Sure. Next question, please.
For question 7, I just wanted to make sure I was doing this correctly. Question 7 asks for the average velocity for the first 4 seconds. And I think the equation that you're supposed to use, the average equals v1 plus v2 divided by 2.
No. This equation you've mentioned gives you an average velocity only for the motion with constant acceleration. This, first of all, of course, is equal to delta x over delta T, because this is a definition of it, but this only for motion with constant acceleration. Always only your graph has, what do you know, velocity. Your graph for velocity as a function of time has the part that represents motion with constant acceleration. So for this part, you could use this equation. But for the whole trip, you cannot, because this part is not the motion with constant acceleration anymore. And
That's motion with constant velocity.
absolutely right. So the whole motion has no name. It's a combination of two. So it was constant acceleration, constant velocity, but the whole has no name. If it has no name, you cannot use any specific equations. Specific, but you still can use definitions, because if you want to calculate average velocity, what is the definition?
I'm a little confused, Professor, because it just says for the first 4 seconds, so why can't you use the MCA equation?
First, maybe, let me read it. I jumped to conclusion. Average velocity for the first 4 seconds. Oh, for that, yes, you can. Sorry.
Okay. Would you use like V initial and then V final, so 0 plus 12 divided by 2?
So for this part, I'm sorry, for this part, average velocity, on one hand, it is equal to this, because it is always equal to this. On the other hand, it is equal to this. And you choose which is 1 and which is 2. You choose which instant you call number 1 and call number 2. Of course, we have to choose according to what is told for the first 4 seconds. The first 4 seconds begin here and end here, right?
Mm-hmm.
So V1 is here, V2 is here.
Okay.
And that is indeed 0 and 12. 0, 12, 2, 6.
And then would we have to figure out like a question that would ask for the average velocity of the entire trip?
Well, yes, because that's what I was thinking about. Because the last part, D, requires exactly that. In part D, you need to calculate total time. Someone's joining. Do you mind if we accept? All right, I'm going to continue first. So the graph is not very visible, but if you could use a ruler, you would see that this line doesn't hit 10. It's a little bit longer.
Mm-hmm.
So to calculate accurately that time, you would need to know total displacement for the first 4 seconds from 0 to 4. And then you would have to add, right? Let me read one more time. You know that yes, correct. Yes. So delta x2 from 4 seconds to unknown seconds together should be equal to 100 meters from 4 seconds. So this is how you should arrive to this unknown, to that time. Hello. Right now, you can join and listen. I have a conversation with a student already. So how do we calculate this displacement for the first 4 seconds? Well, for the first 4 seconds, the displacement is equal to that very average velocity times time times 4. So it's going to be 6 times 4, 24. That's 4 seconds.
Professor, I can't read it well. Could you zoom in?
I'm not sure actually. What I can try is share screen. Can I?
Yeah, now I can see it. Thank you.
But now I cannot see it. All right, now I also can see it. So, what was I doing? I was calculating the displacement for the first 4 seconds. And then it was traveling at 12 meters per second. For how long? From 4 seconds to an unknown. So this time interval is t minus 4 seconds long. How would you calculate the displacement from 4 to t? Well, because now it's motion with constant velocity, it's velocity times time, which is 12 times 4 minus, times t minus 4. That's what you're looking for. So this is 24. And this is 12 times t minus 4. And if you add, you should get 100. And that is how you solve for time. And
Okay.
that gives you not 10, but 10.3 seconds, I think. And if you entered 10, I would think WebAssign would tell you correct, because these 0.3 doesn't make much difference for the WebAssign. It's still less than 4% difference. So, but the actual calculation should give you the more accurate result, 10.3.
Okay. Thank you.
All right. Next question. You've been here first, so.
I don't have any more questions at the moment.
All right. Thank you very much. And who was next? Please, next person. Go ahead, ask question.
I had a question about the lab sections being switched. Like to the lab sections that are available online at the student link. So are we stuck in the lab sections we're signed up for?
Are you talking about 105 or 106? Because in the
105.
105. In 105, the rule was set we have 2 sections, one large, which in the morning, and one smaller, which in the evening on different days. That's what we have. So what your question specifically?
Okay, so when you sent the email, it looked like we were all going to be in the sections that we signed up for. So I was just, okay, I was wondering if it's going to we can still attend Tuesday, Thursday, 11 to 2:30 lectures or labs.
That email, if you read, says PY106. And if you open the file attached, it shows you the lab schedule for PY106. It says PY106, decision was made, we're going to do that. So if your question is about PY105, you're referring to the wrong email.
Oh, okay. Thank you.
No problem. Any more questions? Go ahead. All right. Next.
I also have one question on homework 1, part 2, question 10.
Homework 1. Oh, that's about the boat.
Yes.
Okay.
So when I was looking at this question, I solved, and I was wondering about part 2 and 3 of part A on question 10.
So please explain me in your words what's happening there.
So what I found was
No,
I found the angle
what
that
did you find? What is happening there?
explain what's happening to the boat.
Yes.
So the river is pushing at a speed of, in my question, 2.8, so like north, and the velocity relative to the water, the man rowing the boat is 5.4 meters per second southeast.
And where does he land?
He lands exactly across the river from where he started.
All right. So that, and he travels to the right, to east, right?
Yes, he travels southeast.
No. Or completely different things. Aiming, trying to travel, and actually traveling.
Okay.
How does he actually travel?
He actually travels.
If a person on the ground would be looking at the boat, what that person would see?
I think it would see him traveling directly east.
All right. So this is how it actually travels.
Yes.
So the velocity of the boat relative to the ground, with respect to the ground, points due east. Now, and you say he aims his boat at a certain angle. What is the angle?
The angle was, I calculated and I got it right.
No. So you don't know the angle, you need to find it, right?
I found the angle that he aimed the boat, but the question says at what angle does he travel relative to the eastern direction? I was wondering how these questions would be different.
Well, there's angle he aims, and there's angle he travels. We just have had that discussion, right? He travels.
Yeah.
He travels this way,
Okay.
and how does he aim the boat? What does the problem say?
He aims the boat. I calculated an angle of 31.23 degrees southeast.
So, like this.
Yes.
This is how he aiming. And this is traveling. So, different words, different directions. So, if you use standard reference frame X, Y, or east, north, south, west, this angle from aiming to east equals 31, you say, about. Okay?
Yeah.
So now look at the picture. You can see the screen, correct?
Yes, I can see the screen.
So what is the angle between X direction and the direction he travels?
Would that be 0 degrees?
Do you see any angle?
Yeah, there's no
There is
angle.
no angle. If there is no angle, what number it means?
0 degrees.
0. That's it.
Okay, that was the, okay, thank you.
Sure. All right. Next question, please. Anyone? I can see more people, so please jump in.
Hi, I had a question about homework 1, part 2, question 3.
It's a lady on a rope.
Yeah, the Olympic diver.
This one. Can you see?
Oh, no.
You cannot see.
No, I can see it, but it's not that question.
But that's problem 3. So which homework? Part 1, part 2?
Part 2. Part 2, question 3.
One. Oh. 2, 3. Olympic diver.
Yes.
So she runs and jumps. And then, well, this problem looks very similar to this problem because initial velocity in both cases is horizontal. So the strategy is supposed to be identical. Let's see. We have water. So she jumps off horizontally and enters water. You're calculating what? You're calculating speed. This is your unknown. Final speed, which is actually
Well, like it says right before she hits.
when the projectile moves, velocity changes. So if you need to calculate speed in general, how would you do that? What is the definition of speed at this instant? Instantaneous speed, what is that?
Is this the, well, wouldn't it be 0
No.
at that point?
Well, first of all, you don't know. That's what you're looking for. But the question is not what is it equal to. The question is what is the definition of instantaneous velocity? We used a couple of times because if you don't know a definition, you don't know what you're looking for. If you don't know what you're looking for, you cannot find it. And the definition of instantaneous velocity, instantaneous speed is equal to the magnitude of instantaneous velocity. That's what it is. Speed is equal to the magnitude of instantaneous velocity. Velocity at the instant she is entering water. You need to know the velocity first, and then to calculate its magnitude. If you don't know the velocity first, you cannot calculate speed.
Right.
This is velocity. This is speed. So next question, how do we calculate velocity? Velocity, this blue arrow, that's our unknown now. So we need to use something we know about the projectile motion. For example, the horizontal motion, well, it's a slang, but if we look at the shadow of the ball or her traveling horizontally, that's going to be the motion with constant velocity. This component remains the same, constant. The same means it is now as it was here, it is now as it was here, it is now as it was here. So can you tell me the value for the x component of velocity?
Hold on, I think
It's here as it was here, as it was here, as it was here when she jumped.
right, so it's the value that they give us.
Exactly. This is her initial speed. And different people may have different numbers. So,
Yeah.
well, anyway, what is your number?
Mine is 1.17.
Meters per second.
Yes.
My number on the screen is 5.4. Yeah. Oh no, that's meters. That's height. Yeah, you're
Yeah, that's
correct.
the height
Yeah,
of the
sorry.
diving board.
So you also know the height. Can you tell me your number, please?
Yes, it's 7.7 meters.
7.7 meters. See how much we know. What else actually do we know? For every projectile, automatically we know something very important.
The acceleration.
Absolutely. So we should put it here. We know it points down, so it's negative for this choice of the axis, and it's about 9.81 meters per second squared. Now, does this acceleration affect horizontal motion?
No.
No, but it does affect vertical. And because relative to y-axis, we observe motion with constant acceleration, like a free fall. Without any thinking, we immediately can write two equations, the velocity equation.
Mm-hmm.
What did I do wrong? I have to keep this subscript because it describes only part of the motion relative to y-axis. And the motion equation also should have the same variable.
Yes.
Y, again y times time, acceleration times time squared over 2. But we know this equals to negative 9.81 meters per second. But what else do we know? We know that if we set origin at the lowest point, water, y initial will be equal to 7.7. But when she lands, y final will be equal to what?
0.
0. So we know this. Good. That's final. We know this. We know this number. If we only knew the y component of initial velocity, can you tell me something about this?
Well, if it's at her max, assuming that that's like her max height, isn't 0.
So the y component initially is equal to, please say again?
0.
0. Absolutely right, because this is initially a horizontal arrow,
Mm-hmm.
and horizontal arrow has no vertical component. It would have it. Yeah. Just a reminder. If an arrow points like this, vertical component is not 0. If an arrow points like this, well, actually, vertical component is positive, not 0, negative. But if an arrow doesn't point anywhere and horizontal, there is no vertical component. This is a very important fact, and we use it here. So see how many numbers we know. We know this is 0 because it's final. This is 7.7 because it's initial. This is 0 because it's horizontal. Do we know time?
No.
No, so what do I write?
T.
T. Now, plus negative 9.81 times same t squared over 2. How can you use this equation now?
We could solve for t.
Absolutely. And that is your immediate goal. If you solve it for time, that will, what is it? It's 7.7 times 2 divided by 9.81 and square root of that. I'm not sure. But now, if you know the time, how can you use that?
You would take it
To what equation?
and so the Vy equals Vy initial.
That's why we use names. It's faster. You can say velocity equation and we will know. That's the
Mhm.
velocity equation. And if you, so this is 0, as you correctly mentioned. This is negative 9.81. And this number comes from previous calculation.
Right.
So what did it give you?
I still have to calculate it.
Well, you can calculate it later. But at this point, come on, work. At this point, that gives you this variable, which has a very specific meaning. This is the vertical component of velocity when shell enters water. That's
Yeah.
Vy final. So you know this number now, and you knew this number, Vx. And the question now is, how can you use these two numbers to calculate speed? What do we need to use?
Is it called the Pythagorean Theorem?
Absolutely right. That
Yeah.
Pythagorean theorem. That's how it's supposed to be done. You know this, you know this, and that's your hypotenuse, and that's going to be your answer.
Okay.
Next question, please.
Hi, if that's me, I had a question. I had a few questions on the first part of the homework. First off, I had trouble with, I think it was 2B. Let me go make sure. Right, okay, so with 2B, I think the issue that I'm having, do you need me to tell you what the problem is, or do you have it in front of you?
I need to close something. Need to close this. Or I'm getting confused. I need to close this. Okay, this is, so you're talking about homework 1, part 1,
Yes,
and the problem number
2B.
2B. The magnitude and direction.
I think the issue that I'm having is just that it says north and east, but
What is your path? Different students have different paths.
Oh, I have path B.
Path B. So you start here, you go this way, and you here. So it's 1 block right and 1, 2, 3 blocks up, right?
Yeah, wait, let me see. I have 4 blocks up. So you have 2 blocks down, then 1, 2, 3, 4, 5, 6 blocks to the right.
What is your path?
D.
D? D like
D as in dog.
like a dog. Oh, I see. So in that case, you got 2 blocks down, then 1, 2, 3, 4, 5, 6 blocks to the right, then 1, 2, 3, 4, 4 blocks up, and 1 block to the right. To the left, to the left.
Yes.
Okay. So, and your displacement will look, I'll try to draw it. Your displacement will look like this, right? Can you see the screen?
I don't see anything that you've drawn, no. I'm not sure why though.
How about How about now? Can you see now?
I see the classroom and the board, yes.
Okay. So please tell me. So if you start here and you finish here, this is not your trajectory, right? Your trajectory goes like that. That's your trajectory.
Yes, that's my true.
Yes. And but if you use this part, how many blocks?
It was 6 blocks to the right, 4 blocks up.
Yeah, but now you need to count these blocks inside it, not the whole. 1, 2, 3, 4, 5. 1, 2.
Inside, I'm sorry, where? I think this was a concept I wasn't fully understanding during class.
Can you see the screen?
I can, but it's not very close. So
Very close, very far. Is it better?
yeah, it's better.
All right. So if you start from here and you go this way, this is your trajectory. And of course, your distance will be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Am I right?
Yes, and it's 13 times
13 blocks,
120.
and you can multiply by this number. But if you need to calculate displacement, first of all, you have to know what displacement is by definition. So what is a definition of displacement?
I don't have the textbook definition, but it's the amount of
Well, that's exactly why you're not sure, because you cannot be unsure on definitions. You have to memorize them and know. And for that, you should have it like in your notebook, so you could quickly find it without browsing through pages. If you don't have it in the memory, it's supposed to be on hand. 2 seconds, you found it. If you don't have it, you're losing time. A definition is a vector, an arrow
connecting an
that
initial location.
connects initial and final locations. That's a definition. So if you need to find a displacement, first you have to see it. And for that, you have to draw it. And now, if you need to calculate the magnitude of it, you have to use Pythagorean Theorem. And that's what I was counting. 1, 2, 3, 4, 5, 1, 2.
Okay, that makes so much more sense. I think
1,
I was
2,
trying to find
1,
the
2,
right
3, 4,
triangle.
5.
I
1,
was trying
2.
to find. Oh, sorry.
Yeah, I'm just redrawing the picture. So this is your displacement. So now you have 5 blocks here and 2 blocks here. How do you calculate the magnitude of the displacement?
It's the Pythagorean theorem.
Pythagorean theorem, exactly. And if you need to calculate the angle, first you need to know which angle do you want to calculate. So I'm going to erase this. We don't need it anymore. And we need to read, because you may calculate correct angle, but enter something different. So north of east. What does it mean? It means you need to measure angle from east toward north. And if this is east and this is north, this is the angle you need to enter, right? Maybe not. Maybe this is the angle you need to enter. I actually sometimes get confused with these outdated definitions.
I've been getting very confused with those because sometimes.
Well, this is north of east, and another is east of north. Which of which?
Oh,
Doesn't matter because you have
that
6 trials.
actually helps a lot. The arrow. Okay.
You couldn't calculate anything related to a displacement without looking at the displacement. And you didn't draw an arrow that represents displacement because you did not know the definition of the displacement.
Well, I did the displacement thing, but I wasn't sure how to. This was just something like stupid on my part.
I don't know.
didn't know.
I'm just saying that you have to draw a very accurate picture and you have to start from definitions always. And now this angle theta has a tangent that should be equal to 2/5. And this angle, I don't know how to call it, I don't know, beta. This will be equal to 90 minus theta. One of these should work. So let's see. North of east. According to the answer, this is the angle you need to calculate, I believe. So these are very unclear terms, outdated, but unfortunately, this is one of the best problems besides this on the displacement.
I ended up getting an angle of 21.8014. Let's see.
Well, it sounds reasonable, but now you need to calculate this angle, 90 degrees minus that.
So 90 degrees minus that is 68.1985.
So if I look at the picture,
It's likely
it's-
that the
it's
angle
likely
is-
the larger the angle, but since you have 6 trials, you can try one, and if it doesn't work, it means that is another one.
it was the 21. I put it in.
You put it in, it worked for you?
Yeah, the only issue I have, and the reason this was like stupid on my part, is when I was doing the drawing, I knew that displacement was from start to finish, but I didn't think critically about how to draw a right triangle. So I was looking at, you know how it goes one block to the west?
Oh, I see what you're saying.
Yeah, I really was like, but that's not a right triangle. How
This
am
is
I-
what your picture, right?
Yeah, and I was
Was-
thinking, I can't do the Pythagorean Theorem with that, so.
That
but-
is
but
exactly
until you
right.
drew it the way you did, I was like, oh, okay.
But that is exactly right what you said. I cannot do the Pythagorean theorem. What does it mean? It means you have to do something
You have to manipulate.
to make it possible.
Yeah,
So how do you make it possible? By adding additional elements to your picture. Like this, for
Yeah,
example.
no.
You could have done this. I did this. It does not matter. You say, so, I want to use Pythagorean theorem. Why? Because there is no other way. And then you start looking at the picture and start making by your own hands a triangle that you could use.
yeah.
That's the only way to do it.
Okay, great. I tried drawing out number 3, and I don't think I understand like how to. I even have like the equation sheet in front of me, and I don't know how to like go about this problem at all.
Number 3, this one, you walk for 6.44 kilometers.
Yes.
All right. First of all, I'm sorry to tell you that probably you should have started homework earlier because it's a lot of work ahead of you. This is just a problem 3. This.
Oh no, I have a lot of homework 1 finished. These were just the
Oh,
ones I
okay.
didn't
In that case, I'm sorry. Scratch it up.
No, it's okay.
So that's the right approach. You jump, over a problem, you're confused and you do as many as you can, and then you go to office hours. So, yes, that's your initial location, and you walk a given distance to the left. But that's not it. That's not all. You make a U-turn and you walk again. So this is not the complete distance. It's only a part. Which part? The first part. And of course, every motion takes certain time, and every motion happens at certain average velocity. Well, in this case, it's constant, so just v. These are some variables you can use to describe this part of the motion. And right now, we don't even care about what's happening next. We can start writing definitions, because everything starts from picture and definitions. For example, this is number one. We can write an equation for average speed, an equation for average velocity for this motion. So how do we write an equation for average speed?
Average speed is, where is it? It's L over delta T.
Distance over time.
Yes.
And average velocity.
Average velocity is change in displacement over change in time. So
No, it's
delta
not
R
change in
over
displacement. It's displacement over time, because displacement is change in the coordinate, in the position. This is already displacement. So now, because you have to use these letters, you already have L, but also delta x, and delta x change, which equals final value of x coordinate minus initial divided by this time. You need these numbers, and for that you need to draw x-axis. And now you have to choose 0. It's a number line. It must have 0 somewhere. And my advice always choose it at the most left location. In that case, all values for x will be positive.
Yes.
And now you're done with this part of the motion. But that's not the whole motion, because you make a U-turn and you start traveling back to the original location. Is this your final x?
Going back to the initial position, let me read the problem again.
Yeah, you make a
Well,
U-turn.
I don't think we know, because it says during the trip, how far east did you walk?
All right. So for now, it's a question mark. Can you see this blue X?
I can see that one, yes.
Is this the final location?
I don't think so.
No. So it's not the final. Final is somewhere here, or maybe even further. But this is not the final. So this, I don't know, something else. But what we know, it must be equal to 0, because that is how we set the origin. And now your final. Can you see me?
Yes.
We don't know if you stop here, or maybe you come back directly to initial, or maybe you even pass it. Do it.
Okay.
Do you know where to stop? Here, here, or there?
I don't know yet. I know that he walked 6.44 kilometers west, and then his velocity changed when he started walking east, but I don't know where to stop, and that's what I'm trying to find.
Let me say this first. For the second part of the trip, no matter where he stops, you can write the same set of equations. There is average speed for the second part of a trip. and there is average velocity for the second part of a trip.
It says V what? I'm not able to read the subscripts.
Where do I write? Where? Here. Better?
Oh, yes, absolutely.
All right. So it doesn't matter where that person stops. The set of equations doesn't depend on that. It's the same. It takes a certain time. Hello, I'm with the student now. You can listen and then ask a question. Thank you. So it takes a certain time to travel from 0 to the final destination. Time 2. So these are equations. But if you read further, what does it say about total trip? It tells you something. What?
It tells you that the average velocity, the total average velocity is 1.24 meters per second due west.
Due west. So you can write the third set of equations for the whole trip, for the total trip. Again, you can write an expression for total speed, average total over total time, and an expression for the average velocity. The equations do not depend on what particular part of a trip you're considering, or maybe total. The equations are always the same because the equations depend on the motion. It's motion with a constant velocity. All three of these. But velocity has a direction. This velocity, number 1, points to the left. You know that because the person was walking west. Correct?
Yes.
And now you also know that eventually the person stops in such a way. So average velocity, this one, also points west. How can that be? Where does he stop?
Like which coordinate does he stop?
You don't know that. You cannot say a number, but
Yeah,
you can
exactly. I
something
don't know that.
less
But
specific.
the velocity is 1.24
Yeah.
per second.
But again, the question was, where does it stop relative to the initial location? Does it get back to it, past it, or before it?
I don't think it reaches the original location.
Why? Why you don't think so?
Well, we're not given a time, but
It's not about time. It's not
yeah,
about
no,
time.
I know, but
Yeah.
the velocity is slower than the first velocity we were given.
No, it's not about that.
No.
No. You have to read the sentence. The average velocity points west, and understand what it means. The average velocity points west. So what does it mean?
I feel like that means you went west more than you went east, so it's like pointing in the west direction.
No. The average velocity for the whole trip points west. It means its value, if you calculate it, has to be negative.
Oh, that's all you were asking.
Well, that's what it means.
Yeah.
And if it is negative, hence the total displacement must be negative. And the total displacement, because it's final minus initial, tells you that final coordinate should be to the left, to the initial. That's what it tells you. Not at initial, not to the right, but to the left. So maybe somewhere here. This has to be the final coordinate.
Okay.
This statement about the direction of the average velocity for the whole trip tells you that total displacement for the whole trip, according to a definition of total displacement, must point west, which means overall, over the whole trip, person walks west. Now, this is your unknown, I think. This is what you're looking for. Because the question, how many meters does he travel on its way east? And this is exactly what it is. If this is 0, that's what you're looking for. But at this point, we said everything related to physics. Physics is done. When physics is done, what begins?
Math.
Exactly. So at this point, we have to start using our numbers. We have many equations. 1, 2, 3, 4, 5, 6. Also, we got some connections. For example, if you want to, how do you calculate total distance traveled, total length, L total?
L total would be L1 plus L2.
Absolutely. One more equation, 7. How would you calculate total time?
T1 plus T2.
So one more equation. You see, you got 8 equations for you to consider. And the numbers now. So this, the most left coordinate is set to 0. Okay. This is what we're looking for. There's one more number we need to write, x initial. Can you tell me what x initial is equal to?
Would it not be 6.44?
Well, you probably have to use meters because your velocity is in meters, correct?
Then
Yes.
6,440 meters.
Yes. So and now you are ready to solve it mathematically. Pick an equation, plug in numbers. For example, if you use this equation, number 2, that equation should give you time number 1.
Okay, so
Because,
we're going to
well, you see, for each part of the motion, you have to use final and initial values related to that motion. Can't see it here. X2 final minus X2 initial. So if you're taking the equation number 2, you're starting here, you're ending there. Your velocity is a given number, I think, because
yes, my velocity is 2.5 meters per second due west.
so if it due west and if it points to the left, what does it tell you about this number?
It's going to be negative.
Exactly. If you forget that, and many people do, it will give you a negative time, and that is wrong. Time cannot be negative.
Yeah.
So your velocity for this part of a trip is negative. What number? 2 point what?
2.5.
All right. Doesn't really matter, but this is negative 2.5. You begin here. That's initial 6440. You end up here. That's final 0. You can use this equation for calculating this time.
So what I'm ending up with is 2,576 seconds. That sounds like a lot. But also, even though velocity is negative, do we take the absolute value of the time?
You cannot just take a number and just erase a sign.
Okay,
If your time is negative, you made a mistake because time cannot be negative. If you use
So-
an equation correctly, your time will not be negative, and it shouldn't, because your velocity points west, which means you must use a negative value for that. Negative,
so the distance will also be negative, so x final is considered 0.
well, every part of a trip
Every part of the trip
has initial and final locations. You can move like this. If you start here, this is your initial location. If you end here, this is your final location. If you start here, this is your initial location. If you end here, this is your final location for the first part of the trip. And whatever number you read here, that's the number you have to use in your equation. What is happening here? Yeah. Your
Wow.
equation must match your picture, and your picture must show two locations, the initial and the final. For this part of a trip, there is a final location for the whole trip. It's here. There's a final location for the first part of the trip. It's here. And you need to separate all these instances, locations in your mind. And the best way to do that is saying it out loud, even if you're alone.
Yeah.
Now you have to move on. I say you should use this equation. And I would say you should use this equation. And this equation. So,
Okay.
well, this equation basically tells you that this denominator is equal to the sum, T1 and T2.
Uh-huh.
Come on. My computer getting slower and slower. So V average for the total trip is equal to X final for the whole trip. That is what you're looking for. Minus X initial, and your X initial was 6440 for the whole trip. So you move like this. That's X final.
Mhm.
And you have to divide by the total time, as you said, T1 plus T2. And T1 is equal to a certain number, whatever it is. Now, this is a given value for you, I think. Is it? I don't remember. Where's the problem?
6440? Yes.
How far is the from starting point to your destination, the magnitude of velocity? Okay, so you know what number you should write right here, but again, you need to remember this velocity points west.
So it's going to be negative.
So now you know everything. You can finish this problem. That's the math. That's the mathematics. Please do it. And I'm going to ask the next question, you or someone else.
I think someone else was waiting, but thank you.
Of course. So please, next person. Go ahead and ask a question.
Hi, I had a question about adding vectors.
A general question or specific related to a problem.
Well, I get specific because I picked the right image on the homework, but my math is wrong. So I'm trying to figure out if my thinking is flawed somewhere.
This is homework 1, part 2.
Yeah, so homework 1, part 2, the first question
Homework 1, part 2.
with the red and green arrows.
So something like this. What do you need to do? Are you solving basically several problems in one? Part A, then part B, then part B.
Yeah, so it tells us to solve it and then pick whichever we think is the correct tail to point to tail.
So you've got given vectors A and B. So which is which? A has a negative component and a positive. B has, so green is A and the red is B.
Mhm.
Okay. So A, B, and we've got components. Please read me your AX and Y components.
So my A points in a different direction. Well, it's in
Oh.
quadrant 3, but
Okay, you read me components, please.
it's AX is -9, and then AY is -20.
Oh, I see. And BX and BY?
BX is 17 and BY is 8.
Okay, so components change. All right. So in that case, A should look like this,
Mm-hmm.
and B should look like this.
Correct.
All right. And the first question, just add them up, right?
Yep.
So if we need to add them up, let's see what's going to happen in general. The tail to a head rule tells me the resultant should look something like this. So that should be something like this. All right. So Cx has to be equal to Ax plus Bx, which is -9 plus 17, 17 minus 9, 8.
Okay.
And Cy has to be equal to Ay plus By, which is -20 plus 8, 20 minus 8, -12.
Okay.
Got it. So now you can forget about, that's it, you just pick a picture, you don't calculate magnitude.
Yes, it tells us to pick the picture, and then it tells us to add the vector A and vector B to get vector C. Which is,
Okay, you need magnitude and a picture.
Mhm.
Well, in your picture, the black arrow should belong to the quadrant number 4. Yeah.
Yes.
So do you have a picture like, what happened? Do you have a picture like that?
It's so the picture I picked was similar, except if you so I didn't because when I drew it, I drew what you drew. But they have something a little bit different.
Oh, my picture is wrong. I mean, not wrong. My picture is not yours picture.
Yeah, it's not the option on WebAssign.
Yeah, so I cannot see your picture, but you have a picture like that, yes?
Yeah, it's similar. The only thing is that they if you mirror it and then
You cannot mirror it.
Yeah, so like they have the triangle instead of it pointing in quadrant 1, they have it pointing in quadrant 3.
Do you have a picture with an arrow, black arrow that points like this?
Yeah.
That's your answer. Your picture should have a black arrow that points like that.
Okay.
If your vector A and vector B
Mhm.
are given like this, your resultant must point like this. That's it.
Yeah.
And your x and y coordinates, they could be anywhere. It doesn't really matter. You can shift the whole picture, left, right, up, down. So what matters is the direction of this arrow.
Yes.
But if you want to calculate the magnitude, these are your numbers, because you have now the actual vector c, and you know that the x component is equal to 8, and the y component has magnitude of 12. So calculate the hypotenuse, and that's done.
Okay. Yeah, I was calculating the actual value of B and the actual value of A, and then doing the Pythagorean theorem. So I see why that's wrong.
Now let me take a look at the next. You probably have again a different picture. So vector D is kind of trickier.
Yeah, mine is like vector D, and it's increasing A by 2. So multiplying A by 2.
Now you just tell me, read what you see on the screen. D equals
2 times vector A minus vector B.
well, that's exactly what I had.
Okay.
All right. So, but your A still looks
The same. It's in that direction.
yeah, and your vector B still looks this way, right?
Mm-hmm.
So what you do this. So it's 2 times this arrow minus that arrow. If you multiply by a positive number, the result is what?
Lengthening those.
So it's going to have the same direction but twice longer. And what do we do about subtraction?
I don't remember off the top of my head.
No, you don't need to remember because the rule is exactly the same as with numbers.
You keep it.
Convert it to opposite.
Oh, yes. Yeah.
This is basically what you're literally doing. Yeah, I've lost all the directions, but that's the idea.
Yeah, you flip it.
Well, I flipped this, but my angle also is off already. Well, anyway, that's going to be B. Well, this is negative B plus 2A. So the result should look like something like this. See, D. The result should look something like this. And you should have an arrow like that.
Yep.
Now components. If D is equal to 2A minus B, that means, and that's the easiest part, dx equals 2 times ax minus bx, and dy equals 2 times ay minus by. So 2 times, I forgot already. Your values, 2 times
That makes a lot of sense.
Very slow. So -9, -20, 17, 8. -9, -20, 17, 8. That's it. Then you can do Pythagorean theorem, because if this is your actual vector,
Mhm.
this is going to be dx, well, magnitude of this dy, and this will be your magnitude. It's going to be again a Pythagorean theorem. You can see actually your numbers both are negative, which is consistent with the picture. If you have x and y coordinates and something like that happens, the third quadrant, negative component, negative component. You can finish calculations later. You
Yeah.
can-
No, yeah, that's what I was struggling with was the
All right.
actual, but that makes sense because a component, like you were saying, the coordinates, and I was thinking more about it as like the actual vector.
Well, please finish your calculation, and I hope it's gonna work for you. So I have to go now, but right now, a teaching assistant has office hours, so you can switch.
Okay. Thank you so much.
Of course.
Okay.
Bye-bye. Stop share. And close. Save. Close. 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 Save. All right, ladies and gentlemen, this is it.